morning, dear student. Today I am going to discuss with you on problematic soil and their management. In this course, we have already discussed with you about the acidic soil, saline soil, pollution created through the water, irrigation water, and today I will discuss with you about the soil pollution. एक्चुअली सॉइल पोल्यूशन एक काफ़ी बर्निंग टॉपिक है आज के समय में. तो सॉइल पोल्यूशन कैसे पोल्यूशन क्रिएट होता है सॉइल के अंदर. तो एनी इंट्रोडक्शन ऑफ सब्सटेंसेस, बायोलॉजिकल ऑर्गेनिज्म और एनर्जी इनटू द सॉइल resulting in a change of the soil quality which is likely to affect the normal use of the soil or endangering public health and the living environment. This is called soil pollution. Means कोई भी चीज़ अगर सॉइल के अंदर जाता है, कोई भी एनर्जी, कोई भी सब्सटेंस, और वो सॉइल की क्वालिटी को चेंज कर देता है, उसके फंक्शन को अफेक्ट करता है, तब हम उसको सॉइल पोल्यूशन बोलेंगे. नाउ सॉइल पोल्यूशन दो तरह के होते हैं, एक सॉलिड, एक लिक्विड. सॉलिड को वेस्ट बोला जाता है, सॉलिड वेस्ट, एंड लिक्विड को इफ्लुएंट बोला जाता है. देयर आर थ्री पॉसिबिलिटी इफ एनी इफ्लुएंट और लिक्विड पोल्यूटेंट रीच एट द सरफेस ऑफ द सॉइल. देयर इज थ्री पॉसिबिलिटी. फर्स्ट पॉसिबिलिटी क्या होगा कि वह जो पोल्यूटेंट है वो आइदर वॉश आउट हो जाएगा रेनफॉल होने के चलते, या दूसरी जगह वो कैरी ऑन हो जाएगा. दूसरी पॉसिबिलिटी ये है कि जो ही वह सॉइल पर आया वो क्या होगा, वहाँ पर इवेपोरेशन होगा उसका, वो वोलेटाइल हो जाएगा एंड दैट विल रीच इन द एटमॉस्फेयर एंड मे बी अफेक्ट द एटमॉस्फेरिक एयर. सेकंड पॉसिबिलिटी. थर्ड पॉसिबिलिटी जो सबसे डेंजरस है कि आइदर वो इंटर करेगा सॉइल के अंदर थ्रू द इनफिल्ट्रेशन, एंटरिंग इन द सॉइल इनफिल्ट्रेशन, और वो कैरी ऑन होगा थ्रू द सॉइल प्रोफाइल, और मे बी दैट एक्यूमुलेटेड इन द राइजोस्फीयर जोन इज डिपेंड अपॉन द इंटेंसिटी ऑफ द coming pollutant on the earth surface, and that will reach at the that will carry on up to the aquifer or underground water. So there are three possibility. If any effluent reach at the surface of the soil, one is there is a possibility to wash out. Second is that convert into the vapor in volatile and reach in the atmosphere, and third that will reach in the underground soil profile. Now soil health. Actually soil pollution I have already discussed in my first slide कि any entry of the energy, biological organism or any substances that change the soil quality. So that soil quality define the inherent capacity of the soil, and that controlled by the four components. One component is the physical environment of the soil. Second component is the chemical environment of the soil. Third is the biological environment of the soil, and organic matter play an important role to integrate all these three to develop the soil quality. Now soil function, actually that entry of the pollutant disturb the soil function, normal soil function. So these are the some, you can see in the slide, these are the some important soil function. First is the sustaining biological activity, diversity and productivity. Second is the regulating and partition of the water and solute flow. Third, most important, it can be act as a filtering, buffering, degrading immobilization, detoxification, organic and inorganic material, including industrial and municipal waste. Now, next is the storing of the cycle. Soil is a storehouse of the nutrients, and all nutrients are stored in the soil system, and through the plant system it reaches in the edible parts of the plant, and by default all the nutrients from the plot reach at the plate via edible part of the plant. So for human health point of view, plant health point of view, animal health point of view, soil health is the most important in recent scenario. Now, providing support to the socio-economic structure and protection of the archaeological treasury association with the human habitat. Now, second terminology always used among the scientists, among the farmers, that is soil contamination. Any addition to the soil of substances that may exert adverse effect on the functioning can be defined as a soil contamination. I have already discussed what are the important soil functions, and that function disturbed due to the any changes in the soil character, soil quality, that is called soil pollution, also soil contamination. Since soil poses buffering capacity. Buffering capacity means if any unwanted or material or energy when enter into the soil, soil property cannot change drastically. This is called buffering capacity. Means our soil resists to maintain the normal condition. But if that situation did exceed to the critical limit, then after negative deterioration in the soil system have been started. So it usually takes some time for negative effect due to the buffering capacity of the soil to become visible impact of any contaminant. Now, what are the source of the pollution? Very clear. First source of pollution is our industry. There are so many wastage, solid waste, effluents released by the industry, as for example, fly ash through the thermal power corporation or other effluents from the different metallurgical industries. Now second is the high analysis chemical fertilizer. Use of the high analysis chemical fertilizer today, it has less impurity and high content of the nutrients. Use of the pesticide, weedicide, insecticide also affect the soil pollution. Now, use of the sewage sludge, city compost and other industrial waste also responsible for the pollution of the soil. Now, last is the nuclear waste is the most important, it affect the soil quality. Now, major reason of the heavy metal, as you know, all the elements which have their specific gravity more than 6 comes under the category of the heavy metals, and most of the heavy metals are dangerous for human health, also plant health. So, these are the some sources from which heavy metal reaches in the soil system. One is the sewage sludge and urban compost. Second is the agrochemical, pesticide, fertilizer, etc. Vehicle exhaust, and through this lead reaches at the soil system, in the soil system. Residue from the metallic ores, mining and industry, metal asthmatic industry, electroplating, radionuclide, anthropologic sources, मतलब we are also responsible to pollute the soil system. Now, ये सब कुछ photographs हैं, you can see here. Now, this is the most important कि sources may be agriculture sector, domestic sector, industrial sector or nuclear sector. But all the pollution created through these sources carry on, go through the different ways, but lastly that will reach in the land and water bodies and main disposal site of the waste. So all the pollutant either that will produce through the agriculture sector, industrial sectors, domestic sectors, carry on through the different sources, different energy, but lastly that reach at the land and water harvesting tank or water structure. So this is the last disposal of the any polluted land and water. Now, although soil acts as a physical filter, no doubt, it has a capacity to filter all the pollutants that enter into the soil system that have already discussed. Third option, by sieving action. Second is the chemical filter by absorption, precipitation, transformation and chemical substances. Actually, soil is a test tube and automatically there are so many reactions takes place within the soil system. So through this reaction that pollutant may enter into the soil system, that may be good through at the absorption side, at the precipitation side, or that may be transferred or that may be transformed into the different chemical substances that may be not harmful to the soil system, that may be developed a good character into the soil system. So these are the different chemical reactions always running in the soil system. Third is the biological filter by the decomposing organic material. Actually, any organic material when entered into the soil due to the microbial action, that decaying of that microbial organic matter has been started and their pollution is reduced day by day. Now, but these does not leave infinite capacity to perform this function. These are the functions that act as a safeguard to the unwanted character developed in the soil system through the addition of any pollutant. But these have a limitation, and up to a critical limit it protects our soil. These all characters protect our soil, but when pollutant load is ever or more, then this action failed, and after that our soil character deteriorating and there are so many abnormality in the soil system have been developed and that affect the normal function of the soil system. Now, fertilizer. Always in the society, question arises that our application of the fertilizer deteriorating the soil health, and that will be the dangerous for the human health also. So today I will discuss about the fertilizer, how fertilizer act in the soil system. You can see in the slide, fertilizer cause yield increase, no doubt. Because today our farmers are growing high yielding variety, hybrid variety, and that variety needs more nutrients for their potential yield. So, fertilizer application is a mandatory or essential to produce higher production through the high yielding and hybrid variety. But imbalanced fertilizer use cause yield decline and deterioration of the soil health. Main problem is कि यदि हम असंतुलित खाद खेत में डालते हैं वहाँ पर प्रॉब्लम क्रिएट होता है और उससे हमारा सॉइल का हेल्थ डिटोरिएट होता है. तो इम्बैलेंस फर्टिलाइजर यूज कॉज यील्ड डिक्लाइन एंड डिटोरिएट द सॉइल हेल्थ. इट इज द मोस्ट इम्पॉर्टेंट पॉइंट. नाउ यू कैन सी इन when green revolution was started in 60 to 70, that time when farmers was applied 1 kg fertilizer as a NPK for, they were get 12 kg additional yield through their crops. But that scenario has been changed due to the increasing year by year. You can see in the slide. At present, when one farmers applied 1 kg fertilizer, they will get only less than 5 kg response or additional grinding. This depend upon their management of the crop. So depletion of the inherent capacity of soil due to the imbalanced fertilizer application and inorganic secondary and micronutrients management. Actually क्या हुआ कि जब इनिशियली पहले फैलो लैंड था उसमें जितने भी हमारे सॉइल के अंदर essential nutrients, as you know, there are 17 essential nutrients that needed for proper development of the plant. उस समय सभी का एक बैलेंस अवेलेबिलिटी हमारे सॉइल के अंदर था. उसके बाद ग्रीन रेवोल्यूशन शुरू हुआ. व्हीट क्रॉप, राइस व्हीट क्रॉपिंग सीक्वेंस इज द मोर पॉपुलर अमॉन्ग द फार्मर्स. उसके बाद इंटेंसिव क्रॉपिंग शुरू हुआ. उसके बाद हाई एनालिसिस फर्टिलाइजर आया, लो यूज ऑफ ऑर्गेनिक मैटर हुआ, मैकेनाइज्ड फार्मिंग हुआ. इससे क्या हुआ कि धीरे धीरे हमारा जो स्टोर हाउस था सेकेंडरी एंड माइक्रो न्यूट्रिएंट्स का वो डिक्लाइन करते हुए चला गया. और एक भी अगर न्यूट्रिएंट्स की कमी होगी सॉइल का वो उतना ही हार्म करेगा, उतना ही यील्ड पोटेंशियल को रिड्यूस करेगा जितना कि प्राइमरी एंड सेकेंडरी न्यूट्रिएंट्स का हार्म होगा. तो अभी जो एसेंशियल न्यूट्रिएंट्स जो एप्लीकेशन ऑफ द फर्टिलाइजर गिविंग लेस रिस्पॉन्स, दिस इज द मेन रीजन कि आवर सॉइल हैव imbalance availability to all the nutrients. So for this we have to think on the site specific nutrients management. Now next is this is the nutrients consumption ratio in the India in 1950 51-52. Ratio is about 8:1:1, means 1 kg phosphorus, 1 kg potash and 8 kg nitrogen was applied by the farmers in their field. But that ratio have been declined and at present that have reached 5.9 nitrogen, 2.3 P2O5 and 1 kg phosphorus. But this ratio is also imbalanced. Fertilizer or imbalanced nutrients application. Actual balanced nutrition application is 4:1. If farmers applied 4 kg nitrogen, they have to apply 2 kg phosphorus and 1 kg potash also, and on the basis of the soil test, they have to give more emphasis on the secondary and micronutrients supplement in the soil. And if through this there is no chance to the pollution of the soil through the application of the fertilizer. Now the increase of the nitrate in the drinking water due to the excess use of the nitrogen fertilizer and animal manure is regarded as the most important fertilizer related problem. जो हमारा नाइट्रोजन application, you have already seen in our first slide, in recent scenario also, nitrogen application is more as compared to the phosphorus and potash. In this scenario, what happened? Our applied fertilizer cannot be utilized by our plant system, and that leads down and go through the seepage, go through the volatilization, means go through the different way of the losses of the nitrogen. One of the most important is the leaching, because nitrate is the highly soluble in the water, and that dissolve in the water and percolate through the soil profile and reaches in the aquifer, and then our drinking water contains or concentrated more than 10 ppm nitrate solubility, then that will affect our child through the development of the blue baby syndrome. Now the excess nitrate reached below the root zone constitute a potential threat for the surface and groundwater body. I have already discussed. Nitrate, when denitrified, what happens? N2 and N2O gases leading to the global warming and develop the greenhouse effect in the atmosphere and increase the atmospheric temperature. Now, nitrate can also be absorbed in large amount by the plant, particularly fodder and vegetable, and may result in the nitrate toxicity, particularly the plant belong to the Chenopodium family, to the consumer. Now, high soil nitrate level and sufficient downward movement of the water to move nitrate below the rooting depth, the consumer of the water containing high level of the nitrate nitrogen lead to the methemoglobinia called blue baby syndrome in fact of the age of the less than 6 months, and this type of the disease generally very common where high fertilizer application is in the practice. Now the World Health Organization standard for drinking water is 10 milligram nitrogen per liter, and excess, you can say ppm also, and excess indigestion of the nitrate may also increase the risk of the cancer in the human due to the formation of the nitrosomania. Now, what are the strategies for minimize the adverse effect of the nitrogen use on environment? There are two ways. One is the optimum use of the nitrogen as per availability of the plant utilization. मीन्स प्लांट को जितनी आवश्यकता है उतना ही आप फर्टिलाइजर डालिए. हम फॉर एग्जांपल यदि उसका नाइट्रोजन का यूज ज़्यादा है, सपोज सीरियल्स आप लगा रहे हैं, राइस लगा रहे हैं, मेज लगा रहे हैं, व्हीट लगा रहे हैं, दैट क्रॉप्स नीड ए हाई अमाउंट ऑफ द और यू कैन से दीज आर द हेवी फर्टिलाइजर और न्यूट्रिएंट फीडर क्रॉप. बट यदि आप लिगूम लगा रहे हैं तो ये न्यूट्रिएंट्स लेस रिक्वायरमेंट होता है, फास्फोरस का रिक्वायरमेंट ज़्यादा होता है, नाइट्रोजन का कम होता है। तो इस पर हम लोगों को विचार करना पड़ेगा कि हम उतना ही नाइट्रोजन और फास्फोरस डालें। उसका एक क्रिटिकल स्टेज होता है। सपोज कि हम राइस का एग्जाम्पल दे रहे हैं कि राइस का एक क्रिटिकल स्टेज सपोज कि 21 और 25 डेज के बीच में आता है, डेट इज कॉल्ड टिलरिंग स्टेज। उस समय वो ज़्यादा न्यूट्रिशन की आवश्यकता होती है। यदि हम उसको कॉन्साइड उसको देखते हुए हम फर्टिलाइजर का एप्लीकेशन करेंगे तो आवर मोस्ट ऑफ द फर्टिलाइजर विल यूटिलाइज थ्रू द क्रॉप सिस्टम। सो वी हैव टू note or we have to take care for their critical growth stage, and that critical growth stage must be correlated to the applied fertilizer. Second is the direct reduction in the rate, duration and extent of the losses of the nitrogen to the environment. If nitrogen reaches in the soil system, we have to protect the denitrification process, nitrification process and also the leaching process. Through this we can increase the use efficiency of the fertilizer or nitrogen. This is a very, for example, this is a very simple technique. If we use neem coated urea, then their use efficiency have been increased. You can see in the slide, blue bar is the neem coated rice and wheat. So grain yield quintal per hectare increased by the neem coated urea. Now this is the most important function always takes place in the soil system. There are two functions always takes place in the soil system. One is called mineralization and second called is the immobilization. In mineralization system, all the unavailable form convert into the available form and that will utilize through our plant system. But in immobilization system, all the available form that remain into the soil system and also on the exchange system in the soil system or colloidal system, that may be converted into the unavailable form, and this is the reverse condition. So these two type of the function always takes place in the soil system, and our farmers and our soil scientists will already care this function. In which situation mineralization will take place, in which situation immobilization will take place, and if their symptoms, their character will reflect, we can manage our soil system. So you can say in this system, this is called nitrification process, and in nitrification process there are two steps mainly. In one step, ammonia convert into the nitrite, and in this step nitrosomonas bacteria, it is a bacterial activity or bacterial process of conversion of ammonia into the nitrate, and there are two bacteria, one is the nitrosomonas and one is the nitrobacter. So nitrosomonas convert ammonia into the nitrite and nitrobacter convert nitrite into the nitrate. So these two, first is the ammonia and last is the nitrate utilized by our crop system. So if our nitrogen retain in the soil system a long time in the form of ammonia, then their use efficiency may be increased, because nitrate when converted into the nitrate, it is highly soluble and there is a more chance to leach down, and again it go into the denitrification process and into gases form and escape into the atmosphere. So chances to reserve the nitrogen, if our nitrogen sustain in the ammonical form in the soil system. So there are so many nitrogen salts and different type of neem also act as a inhibitor action. So this inhibitor action that reduce the activity of the nitrosomonas, so that our conversion of ammonia into the nitrite is very slow, and that retain into the ammonia, and use efficiency of the nitrogen will increase. Now, there are others management option. It is a long chain of the management option, but I have only the I am here only with the bullet point, some bullet points that may be considered to management of the nitrogen into the soil, and we can save our soil deterioration due to the excess nitrogen concentration in the soil system, also in the water system. First is the most important, minimize loss of the soil nitrogen. We have to reduce to application of the nitrogen fertilizer. Second is the increased nitrogen use efficiency. I have already discussed. There are so many ways to increase the nitrogen use efficiency. For example, I have already shown a neem coated urea can increase the nitrogen efficiency through the less solubility of the granules of nitrogen in the soil system, and also act as an inhibitor to reduce the activity of the nitrosomonas bacteria. Third is the crop management practices. It is the most important, crop husbandry. Through the crop husbandry, we can manage the nitrogen losses, nitrogen utilization by the crop. Second is the site-specific nutrients management. This is a very technical aspect. If we go in the field for the purpose of cultivation of a crop, we have to decide which crop we can grow in the soil system on this fertility rate. So first our objective to take the composite soil samples, and we have to send in the we have to reach in the soil testing laboratory to know the fertility status of the soil, and after that, as per the crop's need, we have to define if our soil is deficient, then we have to what amount we have to apply the nitrogen. If our soil is sufficient, what amount of the soil we have to curtail. So this all aspect we can do through the site-specific nutrients management. Now fertilizer placement is also a very good technique. In this technique we use this fertilizer in the root, rhizosphere zone, so that our root can utilize maximum of applied fertilizer, and our nitrogen less goes through the different type of the losses process. Now proper type of the fertilizer, it is also important as per the soil character. If acidic to our soil may be acidic, may be saline, may be alkaline. So in the market there are so many fertilizer as per the soil character are available. As per example, ammonium sulfate is not suitable for the acidic soil, but it is suitable for the neutral and saline soil. So we have to think on this aspect. And last is the use of the nitrification inhibitor. There are so many nitrification inhibitor. For example, insert available in the market, and if that applied to the fertilizer, our nitrosomonas activity can be reduced, and we can enhance our use efficiency of applied nitrogen fertilizer. Thank you. This is the soil management. This is a message. Soil pollution needs macro attention in recent scenario for healthy ecosystem. Thank you.